So today we are going to talk about create table operation first and then join operations. Different kind of joins basically. So we are going to create a one database wherein we will have two tables, right? And then we will insert some data into it, and then we will try to create a join operations on top of it. Okay. So let me create one schema. Okay, so let's go to the database. So I have logged in as a SQL Server Management Studio, and then my database is MS SQL Server, and I am creating a new query. Right, right click on the database and then click on new query. So you will have. I'm going to create a schema first. So there is a statement called create schema. Schema name. Uh, uh, test. Let's say test db is the schema, so column, and then you try to execute it. So your schema is get created. Okay, once the schema is created, so I'm going to create one table that is called departments. So I will create in my schema, okay, test schema. Herein I'm taking two columns actually, name and id, department name and id basically. So let's execute this command. So this my ID name is not null and name is varchar. It is also not null. So both of these columns are mandatory columns. Whenever you specify not null constant, and my primary key is ID. Okay. So let me create the table. You execute it. So table is there. So if you look at if you refresh it, so you will have a table called department in test DB. So let's go to the test DB. So if you look at here, so this is my table. So you will have two columns, right? PK. So whatever is the primary key column, so this key sign will be there. And name is varchar 25, not null, right? So this table is created. Now let's try to insert some record into the table. So I prepared this already actually. So let's insert into the this table. So I have inserted some 8 record. If you query this table, if you go to the select top 1000 rows, you will have 8 rows, right? So you can see the tables. Now let's create another table. So because we are learning the join, right? So join is not possible between without two tables, right? So my department is prepared. Let's create the employee table. So I'm going to remove these basically. Okay, I'm removing the constant and I'm giving the test db as a schema. Okay, because I have another schema. Okay, if you look at the tables, if you refresh all the tables, you will see the employee table again here test db. So you will have these columns in the table. That key is the primary key. Okay, now let's insert some record into the employee table as well. So these are my insert query over here. So insert query is very simple. You insert into table and give the schema, insert into the table, then you specify the sequence of columns and then values, and then you know one by one all the records you specify. I'm inserting 4 records over here, right? Let's me insert one more record. That is called ID fifth. My department, let's say, what are the different departments I have? Let's say it's department number 9, which is not available because this record will help in join to understand the join efficiently basically. So let me insert this. I will give the name as, let's say, giving the name is this one. Let's say I'm giving this one as Dean. This also is a syntax near year 41. Right. So let me see the all the records, right? So I have prepared the tables and then I have selected here also. I have prepared the tables actually. I inserted some records, okay. And then let's query the table. Select all from testdb dot departments. Let's say, and also db dot employee. Let's say. So we have 5 employees and we have 8 departments, right? Now let's try to understand the join operations actually. So I have prepared this PDF, okay. We will see every possible join, okay. So this is going to be a inner join, the first. If you look at this picture, right, I'm just zooming it. So uh, I have given the MyDB as a schema, but you can give test DB, right? So I have created a MyDB already, basically. So what you can do is you can replace it. So if you look at this picture, right? So let's say this is the A table and circled A, all the data related to A, and this is B, and they are intersecting with, this intersection region is called a common region of A and B, right? So when you denote in a algebraic notation, right? If you might have learned in mathematics backgrounds, and you must be heard about arithmetic. So this notation is A intersection B. So that is called inner join basically. So concept comes in mathematics first, and then we try to implement in various real-time examples basically. So this is the arithmetic, the join operation, inner join operation is the arithmetic operation basically. So A intersection B. So A and B are the two data sets, and we are taking the intersection of it. So the query becomes select all from MyDB table A and inner join this one, right? If I select it and if I try to execute, right, in my database, so what I will do is I will replace test DB with my DB, and that's all. All right. Let me run the query. So every record, the common record will come. Okay. All the record which are common between. So based on department, A dot department ID, employee dot department ID is equal to B dot ID. B dot ID in the sense B, what is B? B is departments. B is departments, right? So I have alias. This is called alias actually. So you give the shorthand name. So that is called alias. on the fly because it's a lengthy name. So I don't want to repeat in the where clause on condition. So I give a shorthand name and now I refer it as A and B, right? Further, basically. Whenever it appears in my query first time, I'm label it as a or alias it as a different name and then I refer it. So that I don't have to use again and again, right? So in between, we are going to learn many more things actually. So we have learned about, right, the not null and creation of the table, creation of the schema, and how to insert that values into the table, right? So on the way, we are learning multiple things basically in the join operation. So this is inner join basically. So inner join test db dot departments, everything from the test department which is equal to the department dot employee dot department id is equal to department dot id. So these are the four record will come basically 1122 21. All the four departments are available in department table, right? And we have people who are working in 1121. Only the ram did not come, so this fifth record did not come because it is in the department number 9 is not available in the department table, right? If you look at here, 9 is not available, therefore we don't have the this 9 wala record in result, right? So if you okay, so that is called inner join basically. So if you want to denote it as a mathematically, so you can denote it as a intersection b basically. Now look at the left outer join, left join and right join basically. So like look at this picture on this left side. So if we want to retrieve the only record which are available in A only, they should not be available in B. So how do you denote? A minus A intersection B. So you take the entire A and you do the minus from this intersection area, right? So that's when you receive this red portion. So that is called left join. So if I copy over here, if I copy this query and I'll try to execute this query over here. So what I will do is I would be replacing my schema. That's all. See, okay. So I said right, only one record will come because RAM is not available in department table at all because department ID 9 is not available. So nothing from B will come, only which is available in A will come. So my query is, when you do the left join and then if you do the left join, then what will come? Everything this all or this all will come. But you want to remove where b dot id is null. So b dot id will be null over here. Okay. If you look at the b dot id, so id and name of b. So b is what is the b? So b is the both the column will be selected. These column are from B table. B table in the sense of department table, basically departments. So you have to select only from table A, employee table. You don't have to select B, right? Where B dot ID is null, right? So this is how we achieve this one. And similarly, if you want to achieve this one, so you do the right join and then you do the so B minus A intersection B is B entire B, and you want to subtract from this area, the intersection area, right? This common area you want to subtract from B. Then only you will give the red section area, right? B, only B part. There won't be no A record. So if you query this, I will replace my schema and you receive the all the records from A. Right? Nothing from B will come. You can pick and choose the columns whatever you want to select. I have given star, so everything is getting selected. You can select the ID and name. So basically it is all the department ID which are not related to employees. So not, no employees is belonging to these departments from 3 to 8. There is no any employee belonging to these departments basically. The meaning of this query is, no employees belonging to any department, that kind of query if they want to select, right? Now go to the complete left join. So complete left join is like A union B, all the A union B means entire thing, and we want to remove the A part. So this white portion will come. Okay. So let me run this query. So I will replace the schema name and then you try to execute it. See over here, right? Okay. So this is a left join basically. So herein what is going to happen is everything from the table A will come, irrespective of whether the record is available in table B or not. So everything from the A table will come. So everything is from table A in the sense of we have 5 record from table A, right? So all the 5 record will come from, because it's a left join. So everything from A came, right? So similarly, this is the scientific notation A union B minus A. So this white portion is the denoting the this one, right? Now let's run this query. I'm replacing the schema and let's say this one. So everything from department table will come. So the you know fifth record did not come, right? 1 2 3 4 came, but fifth record did not come from that table A. This RAM did not come, right? That we don't want. Everything from the B will come. Okay. Okay. A union B. Actually, let me, I think. So, okay, everything from A will come, right? Yeah, there is this red portion. A union B minus this white portion I want to remove, right? So this notation is wrong actually. So this also notation is wrong. So I want this red portion actually. So A union B minus A actually. Let me see how I can represent it. I can just represent A, right? Only A. Yeah, this is A and this is just B. So this is not there actually. Just remove this. I'll correct this picture actually, but this is wrong actually. This notation is wrong. So this is entire B, only B, and this is only A. That's when the left outer join or right outer join actually. This is left outer join and everything from A. This is red portion is the our intended area basically. So let's talk about the another which is full outer join. So let's talk about this one at last, this portion. Let's talk about this one first. I will. So the denotation, if you denote the algorithm, algebraic notation of this full outer join is A union B basically. So I will replace this with the new schema, and then I will run. So everything will come from A and B both. Okay. So see, all the 5 record from employee table and all the department also came, right? We don't have any record available for department number 9, which is available in A basically. In practical, this is not going to happen because we apply the constant. So if you apply the constant, therefore I did not apply the constant. This foreign key constant I did not apply. We will understand about the key constant actually. So this was the simple join condition. So I removed this constant so that it allowed me to insert this record basically. So then all the record from both of these table will come in the full outer join basically. Now we'll talk about this. So this is A union. If I want to receive uh, uh, the records, right? Which are the red portion actually? Let me. I want to receive this red portion. A union B, entire A and B, but I want to subtract the white portion. White portion is what? White portion is A intersection B. So A union B minus A intersection B is this red portion. Not common area, either A or B. not A or B, A and B, right? So this kind of query, if you want to write, right? So this is how you can write the query actually. So I will copy it and I'll paste it over here and I'll replace the schema and run the query. See, nothing common came, right? So we don't have anything or b.id is null. A.department ID is null or b.department ID is null. Okay. Where? So what we received is like the common we did not receive, right? Anything which is in common. What is common? 112 department, right? So what is A intersection B? I think this is A intersection B, right? So 1, 2, 3, 4 did not come, right? We don't have 1, 2, 3, 4. Oh wow, 1, 2, 3, 4. 3, 4. Let intersection B interjoin. No, sorry, this I department is 1121. 112 did not come. So nothing has come. So this is how we achieve actually. So apart from the actually apart from these notations, right? These two notations, everything is correct. So I'll correct this notations and then you know um, then I will supply this document actually. Thank you so much. Please subscribe my channel and we are going to see many more videos with respect to SQL operations. Thank you so much.